Hey guys, this is the Unit 8 review study guide. Let's start with the first question. Solve for the height of the tree. So this tree and this man create triangles with their shadows. So the height of the man, the shadow of the man, height of the tree, shadow of the tree. And these triangles turn out to be similar triangles because the way that the sun is hitting both the tree and the man creates these two triangles to be similar. So because these two triangles are similar, these two triangles end up being similar by angle similarity. So what is the consequence of being similar? Well, all the angles are congruent, and the side lengths are proportional. So this little fish symbol is a symbol for proportion. So since I don't really care about the angles, I care about what the height of this tree is, we're going to set up a proportion. So the tree height with the man's height is proportional to the tree shadow length with the man's shadow. So once I have this proportion set up, then I can solve for the height of the tree. So I'll use h for height. Height that I don't know divided by the man's height equals the tree shadow divided by the man's shadow. So now, in order to solve, I can multiply by my two denominators to get rid of the fractions. So multiply by 9 and by 6 to one side, multiply 9 and 6 to the other side. This helps me get rid of the fractions. So my 6's cancel. I'm left with 9h on the left side. On the right side, my 9's cancel. So I end up with 24 times 6. And since I don't have a calculator, I'm not going to multiply this just yet. I'm just going to divide by 9 and reduce the fraction that way. So my 9's divide out. So I have the height of the tree equals, and I know that 3 goes into 6 and 9. 3 goes into 6 twice and into 9 3 times, and 3 goes into 24 8 times, and 3 goes into 3 1 time. So 6 times 2 ends up giving me 16 feet. So 16 feet ends up being the height of that tree. All right, let's move on. Question 2. Solve for the value of x. So in question 2, I have two triangles. One is inside of the other. And here we're going to want to use triangle proportionality theorem. So these triangles end up being similar. The smaller triangle inside of the larger one, they share this angle P. And when we have two parallel lines cut by a transversal, these corresponding angles S and Q are congruent because the lines are parallel, and T and R are congruent because those lines are parallel. Corresponding angles are congruent. So all the angles on triangle PST is similar to triangle PQR. So because they're similar, we can set up a proportion with the triangle proportionality theorem, which basically says that PS divided by SQ is proportional to PT divided by TR. So now let's plug in those values. So we have 6 over 2 equals 9 over x. And again here, in order to get rid of the fractions, I'm going to multiply by my two denominators. So multiply by 2 and x to one side, multiply by 2 and x to the other side. This helps us get rid of the fractions. The x's cancel on the right. So I end up with x times 6 is 6x equals 9 times 2, which is 18. Divide 6 to both sides. The 6's cancel out. 18 divided by 6 is 3. So there's your example for this one, and you guys can work on the other number too. Use this one as an example. On question 3, complete the following proportions using the triangle below. So again, we have two triangles here. One is inside of the other, and segment KL is parallel to MN. That's what this little symbol is letting me know, that these segments are parallel. So when we have parallel lines cut by a transversal, corresponding angles are congruent. So angle K corresponds to angle M, and angle L corresponds to angle N, and J is reflexive, so J is congruent to the J in the larger triangle. Let me put 3 marks here. So J corresponds to J, K corresponds to M, L corresponds to N. These two triangles are similar. All the angles are congruent. So we're going to set up the proportions. JK corresponds to JL. KM corresponds to LN. And you guys can complete the proportions on the other two. So number 4 on the back. Is WY parallel to VZ, and explain? Okay, so I have two triangles here, and the only way I can let you know if WY is parallel to VZ is by seeing if the proportions are congruent, if they're equal. So if I set up a proportion, I can set up XW over the whole thing, or use triangle proportionality theorem and just use this segment. So I can set up XW over WV proportional to XY over YZ, or I can do XW over the entire side. So let's just use the entire side just to practice something different. XV, I want to see if that is congruent, if it's equal to XY over the entire side, XZ. So the question is, are these guys equal to each other? Okay, so I know what the little segments are. XW and WV together make the whole segment XV. So I'm going to add them together to figure out what the whole thing is. So 3 plus 6 is 9. That's the entire thing. And let's add XY and YZ. So 7 plus 4 is 11. And now I can use those proportions to figure out if they're parallel. So XW is 6 over 9, which is the entire thing. Is that equal to 7 divided by 11? So if you guys can't see, you can't determine if these fractions are equal to each other, we can get rid of the fractions by multiplying by both denominators. So multiply by 9 and 11 to one side, 9 and 11 to the other side. My 9's cancel, my 11's cancel. So 11 times 6, is that equal to 7 times 9? So I have, is 66 equal to 63? And that's, no, they're not equal. So WY is not parallel to VZ. Why? Because the proportions aren't equal to each other. So I'll have you guys work on 5 to practice. Um, 6 and 7 are partitions. So we'll do 6 together and you guys can practice 7. Place a point P so that it partitions AB into a 2:4 ratio. Okay, so I am partitioning segment AB. Okay, so my point needs to be somewhere in between A and B, but I want to separate it so that it's a 2:4 ratio. So I want 2 sections and 4 sections. One, 2, and I'm going to put P here. So I have 2 sections to the left of P and 1, 2, 3, 4 sections to the right of P. All of these segments are the same size. There are 6 of them. 1, 2, 3, 4, 5, 6. If I want to separate these 6 sections in a 2:4 ratio, we're going to have 2 sections on the left and 4 on the right. So this is where point P ends up. Another way to write a 2:4 ratio would be 2 with a colon and 4. And this is saying the same thing as here. So I'll have you guys practice point R for it to partition these 6 segments in a 5:1 ratio. You guys can do that one. Now number 9, solve for side ST. And I have 3 triangles here that are all with different orientations. So the first thing I'm going to do is mark up my angles so that I can do this properly. I'm going to redraw these 3 triangles so that they all have the same orientation. So here's one. This is going to be my large triangle. We'll call this one triangle 2. And triangle 3. Okay, so this is going to be my triangle 2 and 3, and then my larger triangle is 1. Okay, so if I notice on triangle RST, which is a large triangle, where's my 90-degree angle at? My right angle, my 90-degree angle is over here at S. So on triangle 1, I want to make sure that I put that angle, make sure it's reflected here. Okay, now here's where I have a little flexibility. I have angles R and T. So it doesn't matter where I put R or T as long as I'm consistent for my other 2 triangles. So let me just put R up here and I'll put T down here. So R and T. That's triangle 1. Okay, so triangle 2 is this guy. Triangle RVS. So where is my 90-degree angle at on triangle 2? So 90 is here at V. V is here. Okay, triangle 2 has angle R. And on triangle 1, I placed angle R up here at the top. So I want to make sure that I'm consistent with R also going up on top here. And the only angle left is S. So I have V written down and R. And to finish off that triangle is point S. There's that guy. The last triangle, triangle 3, where's my 90-degree angle at? Well, it's not written on here, but this left angle on V is 90. These 2 segments together create 180 degrees, so if this piece is 90, this other portion is also 90 degrees. So again, now V is also here. T is on the bottom right here, so I want to be consistent and put it on the bottom right over here as well. T, so I have V, T, and the last one is S. Now, I'm going to fill out all my pieces. So all of our t is 20. So this whole thing is 20. VT is 4. So VT is 4. And since I know the whole thing is 20, this part is 4. The rest of it is going to be 20 minus 4. 20 minus 4 gives me RV, which is 16. So RV is 16. RV is 16. And I want to solve for side ST. So looking at my 3 triangles, where is ST at? I have an ST down here on triangle 1. I don't have ST on triangle 2, but I do have it on triangle 3. So I want to write a proportion where triangle 1 is similar to triangle 3. Make sure they're similar first. So in order for these 2 triangles to be similar, I need at least 2 angles to be congruent. So since angle S is congruent to angle V, angle T is congruent to angle T, angle R must also be congruent to angle S. So I can set up a proportion. So RT on triangle 1 corresponds to ST on triangle 3. ST on triangle 1 corresponds to VT on triangle 3. Now that I have this proportion set up, I can plug in what these values are and solve for ST. RT is 20, ST is X, ST is X, VT is 4. So here's my proportion. This is going to help me solve for X. Okay. So in order to get rid of these fractions, I'm going to multiply by the denominators. My denominators are 4 and X. Multiply by 4 and X. So my 4's cancel out here. My X's are gone. So I have 4 times 20 equals X, or ST. ST is X. X times X, which is X squared. So I have an X here, X, my 4's are gone, I have X squared. Okay. So how do we undo a square? Undo. The inverse operation of squaring is taking a square root. So I'm not solving for x squared, I'm solving for x. So the only way I can get rid of that square is by taking a square root to both sides. Okay, so by taking a square root, I end up with x equals square root of 4 times 20. And I can split this up into 2 sections. Square root of 4 times the square root of 20. Well, I know the square root of 4 is 2, but what's the square root of 20? So I have square root of 20 is 5 times 4. 5 doesn't have a square root, but 4 does. So this is the square root of 4 times the square root of 4 times the square root of 5. Square root of 4 is 2, square root of 4 is 2, square root of 5. So x equals 4 square root of 5. 4 times 20 is 80. This is equivalent to the square root of 80. And if you guys remember, this was ST. So ST is 4 radical 5, or the square root of 80. For question 10, it's a similar question to 9. It'll help if you draw these with the same orientation. So let me draw my 3 triangles so we can set up proportions a little easier. triangle 1, 2, and 3. Call this one 2 and 3. So my larger triangle is triangle 1. A goes here. I don't want to confuse myself, but you can draw this however you want. But since it already has like this structure, I'm just going to copy that here. This is going to be B and C. B and C. Now I'm on triangle 2 now. Triangle 2, where's my 90-degree angle at? Well, if this portion is 90 degrees, these two make a straight line together, which is 180. This guy also has to be 90 degrees. So my 90-degree angle on triangle 2 is here at D. D. Triangle 2 has angle B, and I want angle B to match triangle 1, so I'm going to copy that up here. I want these triangles to be similar. And the only point left on triangle 2 is A. Triangle 3 has a 90-degree angle at D again. Triangle 3 has angle C. Make sure angle C is copied as it is on triangle 1 so that you're consistent. And this other point has to be A. Now that we have this set up, we can plug in the values that we have. So AC is 4. Where's AC? 4 is here. AC is over here. 4. AD is Y. AD is Y. AD is Y. BD is X. BD is X. DC is 3. And all of BC are these two segments added together. So all of BC is BD plus DC added together, which is going to be X plus 3. X plus 3. So that's all my pieces here. Now I can set up a proportion. So we kind of have a choice here as to what we want to solve for. I'll start off with solving for X first. Solve for X. So I need a proportion with my X's. Okay, let me compare. I have information on triangles 1 and 3 for the same information. So let me compare triangle 1 with triangle 3. BC on triangle 1 corresponds to AC on triangle 3, and AC on triangle 1 corresponds to DC on triangle 3. Now I can plug in what the values are. So I have X plus 3 over 4 equals AC 4 over DC 3. So I have this proportion again. In order to get rid of that fraction, on both sides I'm going to multiply by my denominators. 4 times 3, 4 times 3. My 4's cancel, my 3's cancel. They divide out. But you have to be careful here. 3 is being multiplied to everything in the numerator, so it'll help if you put parentheses around it, so you make sure to multiply both of those values by 3. So I have 3x plus 3 equals 4 times 4 is 16. And we're back in Algebra 1. Distribute 3. 3x plus 9 equals 16. Okay, so I need to subtract 9 from both sides. 3x equals 16 minus 9, whatever that is. So 16 minus 9, 7. Divide 3 from both sides. So x equals 7 over 3. This is an improper fraction. I'm just going to change this to a mixed number so I have an idea of what this number is. 3 goes into 7 2 times. 3 times 2 is 6, so to get to 7 I need one more. So I end up with 2 1/3. So this is 2.333333 forever. So this is the value of x. I'm going to end up using this fraction for when we plug it back in over here. So now that I know what x is, I'm going to solve for y. So where's y at? So I have y here on triangles 2 and 3. And I know what x is now, so I can plug in and find the value of y. So looking at triangle 2 being similar to triangle 3, BD corresponds to AD on triangle 3, and DA corresponds to DC on triangle 3. BD is x, and x is 7/3. 7/3 divided by AD, which is y, equals DA, which is y, divided by DC, which is 3. So again, here, in order to get rid of my denominators, I'm going to multiply by 3 and y times 3 times y. So my y's are gone, my 3's are gone. So I have 3 times 7/3 gives me just 7. My 3's cancel with this fraction. So if that's a little confusing, 3/1 times 7/3. I'll just write it here. I end up with 21 divided by 3, which is 7. These guys are gone, equals y times y, which is y squared. So 7 equals y squared. So do you guys remember what the inverse operation of a square is? It's taking a square root. So when we take the square root of both sides, I end up with the square root of 7. So y equals the square root of 7.